Good morning. I'd like to thank the organizers for giving me this opportunity to talk about the project. This is a small aside before the next speaker continues on the details of the ICAL detector. So as the session convener has discussed, there are two things simultaneously that we are talking about in this project. One is the INO lab, the India-based Neutrino Observatory lab, and the other is the ICAL detector that we are going to place in this lab. And the ICAL detector will be the largest but not the only detector that we plan to build in this lab. So what I will talk about actually is, as you can see, building the underground science lab. I don't think my pointer will reach over there, so I think, huh? No, it's okay. So we'll just have to go by whatever, yeah. So this talk will be focused only on the lab and its construction. Due to the very unique nature of this project. A neutrino lab is not just like any other lab that you will build. Many labs exist in the city itself and in India, but this is a little different lab. It's going to be an underground lab, so it involves not just physicists but also engineers, geologists, many other experts. So we have put together this project with the help of many people. So the technical documents that we have used to put this together, first of course the science goals by the INO collaboration, a whole list of FAQs about the project and its scientific goals are available on the INO website. So those who are interested, I urge you to read it. The environmental impact assessment, we are going underground. This is the mountain that you have seen again and again in practically all our talks. We want to build the lab under this mountain, and we know that in India at least, with all our global warming and all our population pressure, mountains are the last places where we have good forest cover. So our challenge really was to find a site where we have minimal environmental impact, and that was helped by not only just the Salim Ali Center, which did the official study for us, but many environmentalists and environmental scientists have helped us to locate a site and given us input as to how we should actually build this project. So that is the second input into our choice or selection of the site. And the third, of course, is the engineering part of the site, and the entire detailed project report, because this project is going to come up in Tamil Nadu, was done by the Tamil Nadu Electricity Board, and they have a tremendous expertise in tunnel construction, and they have done the official DPR for us. So I acknowledge and thank their inputs, and based on these people and the geologists from the Geological Survey of India, I will actually give you the content of how we chose to build the detector, to build the lab where we wish to build the lab. So what is this INO project? This INO project has been approved in principle by the Planning Commission as a mega science project. It will be jointly funded by the Department of Atomic Energy and Department of Science and Technology, and we wish to build it. I don't know, I mean, I'm not attached to this place. I think I would rather be here. Still you cannot see the pointer. Okay. So we wish to build it here. This is Teni district. We are somewhere at the top of the map here on the right hand side. That's where we currently are. So this is Kerala, this is Tamil Nadu. So it is very close to the Kerala-Tamil Nadu border. Very close to Bodinaikanur, if you know where that is. And so the site was chosen because of, as I said, these various considerations. And this lab will host the main ICAL detector. And I want to say at the outset, because there has been some lot of controversy in the press about this, that it has no strategic or defense applications. It is a science lab. Its operation involves no radioactive release, no toxic emissions. It is a pure science lab whose main goal is to do research in neutrino physics. Associated with this lab, we propose to have an R&D center in the nearby big town of Madurai called the High Energy Physics Center Nodal Center, and various statutory clearances have been obtained. As Profula said, we are ready to start this project. So one thing we are very proud of for the first time in India, that we have built a project involving people from various blue dots around India. You can see it practically spans all of India, from A, American College, not quite to Z, but to VCC in Calcutta. So we have many collaborators from many research institutions and universities. It's an open project. We welcome people with interest to join this project. And right now the host institute is Tata Institute of Fundamental Research in Bombay. So I will start now with the main content of this. Why is this lab different? Why is it that it involves so many different agencies? The main thing is that we need to build this detector underground. So why do we need to build it underground? The reason is because of the kind of physics we want to do. Most neutrino labs are underground, and the main reason is that if you look at the left hand side, we have talked about cosmic rays. Cosmic rays are an open problem in research. We don't know where they come from, but they continually bombard the earth, and while bombarding the earth, they produce pions and later muons, and then the muon neutrinos, which is what we will detect in the lab. But before they produce muon neutrinos, they produce these particles called muons, and muons are extremely penetrating particles. And they are not, we always talk about ground, right? Everything is earthed by the ground. So we are not worried when some electrical short circuit, and if it's grounded well, then we are not worried about getting a shock. That is with respect to electrons. But the much heavier muons are very penetrating, and you will find that the muons coming from these cosmic rays can penetrate down to 1 or even 2 kilometers underground, and we have to shield our detector, our neutrino detector, against these background muons. This is the reason most neutrino, or practically all neutrino experiments, are underground. And to give you an order of magnitude, even if we go in the, you can see where we have written over there INO at board. I'm very sorry I can't use the pointer. Professor Kajita, who got the Nobel Prize last year, he works in the lab called Kamioka, which you can see. A little bit below that is INO at Bodhi, the proposed INO lab, a little bit deeper, and you can see that compared to the surface, which is a little more than few parts 10 power 6 muon intensity, when you go about 1000 meters underground, you will have 3 orders of magnitude smaller cosmic ray muon background, which still means that we have something like 3000 muon events per hour we will have at this detector, 3000 per hour. And what is the interaction rate of neutrinos? We expect to see 3 neutrino events per day. So this is the signal versus background that we are fighting against. This is why we need to have really superlative detector electronics that Prafulla just talked about. But most importantly, this is the reason we need to go underground. And as I said, we are forced to go underground because of this one aspect, that we are not able to otherwise manage the cosmic ray muon background. So once we accept that we have to go underground, the primary criteria are safety, because you want to go underground, we will be underground, our students, technicians will be underground. You want long-term safety of the lab, which means you need to find a site which has good rock quality and minimal environmental impact. So this combination is very hard to find, and we found from the geologists that the Chanakite, very solid Chanakite rock, which is mostly found below 13° north latitude in India. So if you draw a line between Chennai and Bangalore, the rock quality south of that is very good quality, and that Chanakite rock, in fact the particular rock that we found, the mountain in Bodhi, is a monolithic Chanakite rock. We believe will be extremely stable and very good for, appropriate for building our cavern over there. In addition, because we are on the eastern side of the mountains from Kerala, it's a very low rainfall, low humidity area, and that is very good for the working of the RPC detectors. So we searched around in Tamil Nadu. We found actually few sites, but we zeroed in on this Bodhi Pottipuram site in Bodhi West Hills as the one having the minimum ecological impact. And you can see from the summary over here that, I'll read only the last sentence, that noting that wildlife is rarely reported in the portal area, the impact of activities on them will be effectively negligible. This is the statement of the Salim Ali report. We also plan, in addition, to adopt best practices with active environmental monitoring all through the construction phase. I have a little more to say about this a little bit later. So this is where we are. I don't want to spend too much time on it because I can't highlight anything. The red line going northwest, the bottom right is where the portal entrance will be to the tunnel, and the top left is where the cavern will be underground, and this is the schematic of the tunnel. So what is it that we are going to have? As the mountain rises on the west, we have a horizontal tunnel going into the mountain. So we plan to build a horizontal mountain because, as Prafulla said, we have to build a detector which contains 50,000 tons, which means 50 million kilos of iron. And you can't do that by taking it down a mine shaft. It's just too massive. So you want a drive-in, drive-out tunnel where you can load and unload these things very easily. And at the end of the tunnel will be this cavern, and inside the cavern complex will be contained all these detectors. and you can see that the overburden is all solid charnockite rock, which we believe will be extremely stable. So this is the cavern complex. The largest cavern will house the ICAL detector, but there will be additional caverns which can do smaller experiments, and there are multiple connections between all these caverns for safety. So, how are we going to manage the environmental impact? First thing, choice of site, miscellaneous point actually. INO site is in seismic zone 2. This is the lowest zone in India. There is no seismic zone 1. This is the lowest in India, so we believe that it's a very stable terrain. Now, how are we going to build the access tunnel and the cavern? We're going to do something called controlled blasting. In controlled blasting, you have a blast which is done 2 to 3 times a day. In the initial stages, only 2 times during daylight hours. Then when you go further in and the impact is very low, you might do 3 pulls a day. Each blast lasts only a few seconds. This is in contrast to conventional quarries where you're doing continuous blasting, the very well understood process of tunneling. And on the right hand side, I'm not sure you can see the labels, but the very exponentially falling curve shows the vibrations as a function of distance, and within about few hundred meters away from the blast site where you're constructing the tunnel, the vibration is going to be less than 1 millimeter, which is roughly the vibration you feel when a truck goes past outside your house. So that means that when you're about a kilometer away, you're not going to feel the impact of this at all, the vibrations or the noise, and so you believe that there will be negligible impact or near, because the closest village is about 2.5 to 3 kilometers away. You don't want to disturb anybody in the vicinity because there will be at least 4 years of construction, and during that time we believe that we can actually manage this whole thing. I also want to highlight the fact that after we have constructed all the caverns, this is just another science lab. At that point it becomes very ordinary, very few people going in and out, and so we don't expect that during the operation phase there will be any impact at all on the environment or on the surroundings or on the people over there. So this has been actually raised many times. People are very curious, can you really manage this impact of tunneling? So I wanted to highlight just 3 particular places where this kind of tunneling has been done before. One is actually the place which has given us a lot of input, which was constructed by the TNEB, which is the Paikara Ultimate Stage Hydroelectric Power Project in Singara in the Nilgiris. Because those Nilgiris mountains are extremely dense vegetation and forested, they decided to build the entire hydel project underground. It has been functioning now for the last 8 years very nicely, and everything from the water pipes coming in to the tailpipes going out to the cavern to the generators, everything is housed underground. It's a very beautiful project. It has more than 13 kilometers of tunnels under the mountains, and there has been absolutely no impact. You can see that right on the top of the mountain on the left is the reservoir. So they have been digging under the reservoir. There has been no impact on the nearby reservoirs, on the dams, on the nearby area, and so it absolutely stands as a testimony to the safety of underground tunneling. Similarly, in fact, the Idukki, I'm talking here in outside Tamil Nadu state, but in Tamil Nadu itself, Idukki and Mullai Periyar are very important for various other considerations, and those tunnels also, which led to from the reservoir to the powerhouse, were under construction for 3 years after the dam was commissioned with no problems to the dam. So we know that we can build these tunnels. The metro tunnels also tell you that there is no difficulty, that in India we know we have complete control over underground tunnel construction. So many of these things, because of the unusual nature of the project, we have been involved in public outreach for many years now. 2 such examples are given here. We had a very large meeting in July 2010 where we had more than 1,000 local villagers who finally gave the official consent to, as you can see, with the full support of the local community, as the then district collector said, that the INO will come up 3 kilometers from the Pottipuram Panchayat, and this is an ongoing effort. I think I personally have spoken in every college in that area. Many schools are there. Many of my colleagues have been talking, not only in the districts in and around Theni and Madurai, but also in the adjoining Kerala, Idukki districts. And one very positive outcome that we are very happy about is that many students in colleges that we have talked to have been extremely enthused and have actually moved to science, because Tamil Nadu has a history of doing engineering. I think probably all of India has a habit of doing engineering rather than science. There has been, I think, a resurgence in the interest in science, in physics. In fact, universities have started offering special papers in MSc in particle physics, which never happened before, and it has been a very, very positive outcome of this whole effort. So this is really what I want to talk about. We are building a different kind of lab. We have involved many people who have all been very enthusiastic about the possibility of having such a lab in India itself. We want to project it as a world-class laboratory. We believe that because already so many people from around India, so many research labs are involved, and we believe that it will actually end up as being a it is in fact already a very immensely ambitious project. It involves cutting edge science and technology. We expect that from Neutrino physics we may actually branch out into geology and biology as well. And I want to highlight one thing: the unique nature of INO and the many disciplines it involves offers immense opportunities and of course also a challenge. You have to get your engineering, your geology, your environmental science and your physics right. But we hope that INO will serve as a model project both for its science goals and its sensitivity to environmental concerns. In fact, already projects such as LIGO are talking to us, asking us how we have been doing outreach. We have not been uniformly successful. We are still trying, and I think many people are taking pointers from us as to how such large projects should go ahead, and we are very proud that we will also be such a model project when we come up. So I think that there are tremendous prospects in the physics, in the technology spin-offs, in human resource development, which we haven't talked about till now, and this is especially so since the project, as has been mentioned, is completely indigenous, and there will be more about this in the next talk. Thank you very much.